Welcome to our webinar. I'm very happy to see so many of you already live here. This is exciting. My name is Anne Pitkänen, and I'm a product marketer here at Leica Geosystems. And I'm thrilled to be your host today, as this will be the first Leica BLK ARC and Boston Dynamics Spot webinar for a while. In this webinar, we'll focus on the possibilities and advantages of mobile laser scanning. You'll hear about different applications, software workflows, best practices, and how to optimize BLK ARC on Spot for our use cases. We'll also explore how versatile the BLK ARC is when Spot is occupied with other tasks. Today, we have a great lineup of speakers, two experts from the BLK ARC product team. Johannes, our business lead for BLK ARC, will focus first on the benefits of mobile scanning. Julita, our BLK ARC senior product engineer, will show what it looks like to use a BLK ARC with Spot. And then at the end, Johannes will show some real use cases of BLK ARC and Spot. Whether you're here to learn how mobile laser scanning could fit your business or simply get inspired, I'm sure we have something for everyone. If you have any questions, add them to the Q&A part. We will write and share answers to all questions after the webinar. So from my side, thank you for joining us, and let's get started.
Thank you, Anne. And yes, I'm excited to be here and talk about the applications we have with our BLK ARC. Good morning, good evening, and gute, wherever you are joining from. Thank you all for joining us today for our webinar about mobile laser scanning. Now let's get started, and I want to jump right into introducing myself. My name is Johannes Hotz, and I'm the business lead for the BLK ARC. In this role, I manage our customer and partner relationships and performed hundreds of proof of concepts. I'm excited to collaborate with you in the future. A bit about my background. I'm a surveyor with 25 years experience at Leica Geosystems here in Switzerland. And I've spent my entire career in the geospatial industry. A little side note, this is a follow-up on our joint webinar with Boston Dynamics. You can see the link above. And I would like to encourage you to watch this webinar if you have not already done so. Now I want to pass the ball to Julita to introduce her.
Thanks, Johannes. Hello, everybody. My name is Julita. I'm the senior product engineer, and I work with the BLK ARC on the daily basis.
Thanks, Julita. Let's get really started. Why does mobile laser scanning matters? I strongly believe that the advantages of mobile laser scanning are big, and in the next slides we want to explain the advantages, but also the differences to terrestrial laser scanning. So, the BLK ARC is a perfect combination of terrestrial lasers and mobile laser scanning, combining both benefits in one single device. The speed of mobile scanners and the accuracy of terrestrial laser scanners. And that's the best of both worlds. Important question. Why is there a demand for a mobile laser scanner when we have the outstanding terrestrial laser scanners like the Leica RTC360? Well, there are three main reasons why a mobile scanner can be the right choice. Scanning while being in movement allows to capture more in less time. Less scanning positions are required and a reduction of human error due to scan shadows and missing links between scanning positions. The aim of the BLK ARC is a fast and accurate data acquisition, thus enabling shorter project runtimes. This is not only an advantage for the user to get more done in less time, it also means shorter interruptions for the client. For example, the production lines. Customer feedback has shown that capturing detailed and precise spatial data is up to 10 times faster than with conventional laser scanning. The BLK ARC also offers mobile and stationary scanning capabilities, something previously unavailable. It delivers high quality, accurate, and dense data sets. Mobile scanning, where speed counts, and if a higher scan density and a higher accuracy is required at a location than simply at a stationary scan. This is a unique combination of speed, low noise in the point cloud, and accuracy. Another key benefit of the BLK ARC is the unique flexibility to mount it on nearly every platform, be it in robots, on fixed installations, or on every mobile platform. Let's have a look in more details. The BLK ARC on robots, like the Boston Dynamic Spot, offers a unique flexibility to the user. Simplified, you can summarize two main use cases. We have already installed the BLK ARC on hundreds of Spot robots, and the strength and power of this combined solution is unbeaten in the industry. First use case is very obvious. I use a robot where it's dangerous for a human. Typical example is the contaminated areas in a nuclear power plant or down in a mine where potential rockfalls are dangerous for humans. A human life counts much more than a broken robot. We have already a very large user base for these type of locations. Second one is where you want to scan constantly the same location. Be it on a construction site, you're in an autonomous mission at night, you monitor the construction progress and verify the as-built within your BIM model. Or if you are on the automotive industry and you need to update your digital twin twice or 3 times a year to keep up with the constant changes that happen in your production halls. Then you can use the BLK ARC with a Spot together to simply walk again and again through the environment autonomously. Julita will explain more about this one in a few minutes. But beside the Boston Dynamics Spot, this wheeled human push carrier is one of the biggest favorites of our customers. And what our customers love most? With this setup, you can scan for hours without getting tired. No carrying of 10 kilos on your shoulder or 2 to 5 kilos in your hand. By the way, we Germans say 2 Maß of beer. But if you have to scan in difficult areas or terrains, e.g. in a robot cell, in an automotive plant or stairs in a building complex, you can also mount the ARC on a handle to carry it in your hand. Of course, you can also mount it on a simple tripod and you perform a stop-and-go scans with this carrier. This is especially interesting on uneven surfaces or again in small spaces. Examples here are e.g. small bathrooms when you scan family homes, grass or outside construction sites where your wheeled robot cannot be used, or in plants where there are many cables, ducts or on the floor. Our customers are using the BLK ARC, as I mentioned before, on various platforms. Of course, on the very well-known Boston Dynamics Spot, a quad-legged robot that can walk autonomously or tail-operated. But beside this one, so we also have wheeled robots supported. But a human is an equal good carrier for the robot, for the BLK ARC. For example, when mounting the BLK ARC on a backpack, or another very common use case is to scan from the water, mounting the BLK ARC on the boat or remote control catamaran to perform scans from the water view. Very interesting to scan bridges, water platforms or aqueducts. Or a vertical winch to scan such shafts, often used in mining or in sewer surveys. But what if you want to scan inside a bridge? An environment that can be very uncomfortable for the human because of size, of dust, of heat in summer. Then you can simply put the ARC on in this example, low-cost remote control car and drive it through this environment. Of course, there are many more professional carriers available, but sometimes easy things do the job very well. But with simply being a bit creative, the BLK ARC helps you to solve even complex problems. I just created a small wooden blade on this toy car, tied it with some cable ties on the car, added a light source, and to ensure it also works in dark environments. In summary, the BLK ARC is a versatile mobile laser scanner that functions seamlessly on both the Boston Dynamics Spot and any manual push carriers. When mounted on Spot, it is ideal for scanning hazardous environments and areas or locations that require multiple scans. The BLK ARC excels in scanning even the most difficult environments, whether it's through a window on a roof or from a balcony. You will see later some use cases. It's also an excellent tool for scanning installations within suspended ceilings or in a room that are difficult to access. If you need to extend your scanning reach, such as for platforms, LPG terminals, or waterways, as I shown before, the BLK ARC can also be mounted on a boat to scan from the water. A common question is about the accuracy of the scan. This can be challenging to answer as it depends on how conductive the environment is to SLAM technology. Generally speaking, in typical environments such as industrial facilities, buildings, or construction sites, the BLK ARC provides a global accuracy of 15 to 25 millimeter without requiring slam anchors or control points to enhance the slam. Our robust triple slam system, we call it Grand Slam, which includes a visual slam, a LiDAR slam, and an IMU, performs exceptionally well and ensures highest accuracies. The relative accuracy, such as measuring the height of button or width of a door, is typically 1 to 3 millimeter, primarily influenced by the noise in the scan. For reduced noise and increased density, you can add static scans, as I mentioned before, a unique feature for a mobile laser scanner. Alongside with the BLK ARC hardware, the software landscape is equally crucial. At Leica Geosystems, we pride ourselves on being a comprehensive solution provider. Our portfolio includes not only the field software and the range of visualization solution, but also analysis and processing software. Let's have a deeper look into this one. In the office, we offer two primary workflows. A cloud-based workflow using Reality Cloud Studio, where ARC data can be uploaded directly from the field, for example, from the Boston Dynamics Spot, or through your mobile app. All processing is done automatically, allowing you to access and preview and process raw data, register it automatically, and stream it to various platforms. Really a fantastic solution if you have this workflow. Another one is using Register, the classical workflow, Register 360, for example, and together is Cyclone 3DR. The major advantage here is that you already own, if you already own an RTC and have the software, no additional investment is needed. You can continue using the same tools, the same software, which has a significant benefit for existing users, not only in terms of cost savings, but also for maintaining a steep learning curve. In the next section, we will discuss the different autonomy options available for the BLK ARC. To delve deeper into this incredible technology, I'll hand over to Julita. Over to you.
Thanks, Johannes. I'm happy to be here today to dive into the innovative world of the BLK ARC autonomous solutions, and specifically our exciting integration with the Boston Dynamics Spot robot. And today we'll explore two key solutions that are revolutionizing automated and remote data collection. First, we have the BLK ARC integration into the Boston Dynamics Spot software, the Spot app and Orbit Fleet Management tool, which we have developed collaboratively through the partnership with Boston Dynamics. And second, we have the BLK ARC UI, fully developed by Leica Geosystems. Both of those solutions provide powerful and efficient tools for a wide range of applications, and they share many similarities, yet are very different and tailored to meet different needs of our users. Then let's begin by exploring the BLK ARC and Spot app solution. This integration enhances existing components like the Spot app and Orbit from Boston Dynamics by adding extra functionalities to them. By installing the BLK ARC extensions, users unlock a new set of functions within the Spot app, allowing to seamlessly control the BLK ARC alongside other official payloads available for Spot. Within the Spot app, we can now trigger BLK ARC actions such as starting and stopping dynamic scans, or triggering static scans and capturing detailed images. These actions can be executed manually or can be integrated into Spot's AutoWalk. And in the Orbit Fleet Management tools, user can schedule reality capture missions to be run at specific time or create a schedule for repeated scans. The BLK ARC Orbit extension allows also to edit existing AutoWalks and turn inspection missions into reality capture missions and download collected data. Now that you are familiar with the features, let's move on to how to use the system. After installing the payloads on Spot, you will also need to install the software extension to add these new functionalities to the Spot app, which is done through the Spot Core IO admin console. And once installed, you are ready to open the Spot app and roll with your scan. For manual navigation, select the Drive mode from the top left corner menu. Navigate Spot using the joysticks and add scanning actions as needed by clicking the white and red plus icon on the bottom right. And from the inspection list, select the desired actions, and it will be performed immediately at Spot's current location. For static scans, there will be an additional menu allowing to select scan density ranging from low to high, or to select custom duration. Now let's discuss how to automate and streamline the data collection with the BLK ARC and Spot integration. To deploy automated missions, start by recording an autowalk, and to do that, select the autowalk mode from the menu and then choose the record option. Name the mission and adjust appropriate settings, and then simply position Spot near a fiducial. Once the fiducial is recognized, we are ready to start. Then we just simply and similarly as before navigate Spot manually along the required route to teach it the new route, and add the BLK actions along. And once the recording is done, we can either download the missions to use it later in orbit or replay it immediately. As you saw, the autowalk can be triggered immediately from the Spot app, or I can also upload the autowalk mission into orbit and control the mission deployment from there. Orbit is the Boston Dynamics fleet management software from where I can either trigger the mission immediately or schedule for later and repeat at certain frequency. That can help collecting the data in the most convenient time, for example, when there's the least traffic on your site. From Orbit, I can also download the data collected during the scanning missions and operate robots remotely if needed. Our Orbit extension allows also to edit existing autowalks and turn them into reality capture missions without the need to record a brand new autowalk. The second solution available for BLK ARC and Spot is the BLK ARC UI. It is a browser-based app that enables users to control the Spot and the BLK ARC manually, as well as plan and execute autonomous indoor and outdoor missions with the integrated GNSS payload. The navigation system built with the BLK ARC UI takes advantage of live streamed point cloud from the BLK ARC, and this allows the system to build a map based on which Spot can successfully navigate around obstacles without the user having to plan a very detailed path. Then the integrated GNSS payload, as mentioned, allows us to support the outdoor navigations and outdoor missions. And to mention a few more features, it's possible to quickly convert B2G files into E57 on board, so while you are on site, as well as import the data directly from Spot to the Reality Cloud Studio. Now let's briefly cover the operation and data collection process. Similarly as earlier, we can distinguish two options of operation. First, the manual operation, where the user controls the robot and scanner via the BLK ARC UI. And second, the automated missions, where the user just deploys a pre-planned mission. Let's start from the manual operation. It is a great option where specific and close control over the robot is required, and also for unexplored previously areas where we don't have any precondition to plan the mission on. The BLK ARC UI allows for all necessary control over the robot and the BLK ARC. We can navigate the robot around, dock, undock, and emergency stop it if required. And as navigating the robot, we trigger BLK ARC to scan the space in dynamic way, as well as trigger static scans and detailed image along. When it comes to automated missions, I first need to pre-plan the mission, and this can be done either in the Cyclone 3DR desktop software or directly in the BLK ARC UI. If the mission has been planned in the Cyclone 3DR, I then need to export the mission file and import it directly into the UI. And once the mission is in, we are just 2 clicks away from having it executed by Spot. Once the mission is started, Spot will follow pre-planned instructions to reach the waypoints. Meanwhile, the BLK ARC will keep collecting the data. The autonomous missions can be run in a local obstacle avoidance mode, which means that the robot will navigate in a waypoint-to-waypoint mode, similarly to the autowalk, or in the global navigation mode, where planning a very detailed path is not necessary, as the system will advance from the live streamed point cloud from the ARC. And based on the stream data, this is the Spot and the whole solution will find obstacle-free path to reach the next waypoint, of course, provided that the obstacle-free path exists. And here you can see the background and the visualization of how the global navigation works. So you see the team is setting up a few obstacles for Spot, and the gray or white points represent the live streamed point cloud. and the blue that you will see just a second represents a preconditioned 3D model imported to the BLK ARC UI. And now, as you can see, as the spot and arc moves, the BLK ARC is picking up the newly set up obstacles, which were not there before in the preconditioned model. And now follow the spot and focus on how it moves between the waypoints. So the waypoints are set far from each other, and the system is able to actively replan the path once it encounters a new obstacle on the way, and just walk around them and reach the new waypoints. Last but not least, I want to highlight the data management possibilities available in the BLK ARC UI. Once the scan is finished, the data is saved automatically in the BLK ARC's internal memory and can be reached by accessing the My Files page in the BLK ARC UI. And to work further with the data, I transfer it to the carrier. That means to the Spot Core IO computer on Spot. And once the transfer is finished, we can quickly convert the scan into a 57 format. After it's done, you can review the point cloud directly in the ARC UI. Then I can also download my data to a hard drive or to my computer, or upload it directly from Spot to the Reality Cloud Studio and enable the team to start working on it immediately and start producing the deliverables. And with that, I will hand back to Johannes, who will dive into the use cases and applications of the BLK ARC. Thanks for your attention, and I look forward to seeing how those solutions can empower your projects.
Thanks, Julita. Amazing. If you want to see the robots in actions, please let us know. Now to the final part, the use cases. This is one of my favorite examples involving a building. In this video, we've captured an old building complex from the 50s, both inside and outside, including the yard and the parking garage. The entire capture took 1.5 hours, focusing on capturing only the first floor of the building, but the rest was fully acquired. Compared to traditional methods, this was approximately 7 to 9 times faster. The deliverables included a 3D point cloud, 2D floor plans, which serve as basis for deciding whether to undertake a core renovation or even to demolish the entire building. With the BLK ARC, it's possible to capture over 1,000 square meters per hour, making it one of the most efficient scanners in the market. The best practice for data capturing is similar to terrestrial laser scanning. We pause briefly in door frames to allow the SLAM to learn the new environment. However, unlike TLS, we only pause for a few seconds instead of the entire duration of a static scan, saving 7 to 9 minutes depending on the scanner used per room. This results in a significant performance gain. Additionally, we performed 1 static scan per room, each lasting 30 seconds. But beside the point clouds, we also captured a panoramic image every second, providing a view into the building. When then importing the data into Register 360, you can decide if you want to have this visual waypoint every 1 meter, every 3 meter, every 5 meter. Now here you can see how these panoramic images look like. Building progress monitoring, scan to BIM, as-built documentation and service, rental space determination, and virtual facility management are just a few common applications to the BLK ARC. In this video, the customer aims to compare the as-built situation with a planned version to identify any kind of clashes. For this case, the BLK ARC was mounted on the Boston Dynamics Spot, as the survey was regularly conducted by the user. Making an autonomous walk robot offers a significant advantage. However, the choice of carrier for the ARC depends on the specific use case and the customer's budget. Ultimately, the customer gained a detailed understanding of the construction's accuracy and the progress. They could even determine what percentage of construction was fulfilled and if they are still on time. Conducting an inner-city topographic survey with a BLK ARC offers several significant advantages. In urban areas, Obtaining drone flight permissions can be challenging, and the terrestrial laser scanning can be time-consuming. Therefore, a mobile laser scanner like the ARC serves as an excellent alternative. This example features a 20-minute scan of the historic Italian village of Castelvetro di Modena in the province of Emilia-Romagna. It beautifully illustrates how comprehensive such a scan can be and highlights the ease of data capture. By simply adhering to a few SLAM guidelines and working methodology, you can achieve excellent and accurate results. The next one is an example of a survey of a road infrastructure. In this instance, the customer utilized a wheeled robot to enhance staff safety, as surveying on busy roads can be hazardous. Using a mobile scanner for this task provides several advantages. First, it increases safety. Second, it allows to faster capture your data in the field. And with the entire scan, it just took a few minutes. And thirdly, it eliminates the risk of missing any measurements in the field, as everything is automatically scanned. The next step in the workflow after field scanning is to create an orthophoto of the point load, which then can be used in a CAD software like Civil 3D or BricsCAD to digitize all assets. An amazing and fast workflow, and I think that's a very good example to utilize the BLK ARC outdoor. This example showcased the as-built status of an industrial facility. Using this point cloud, you can manage the facility, redesign the production site, or determine whether new equipment can fit through existing doors, and if there's sufficient space for it. Captured with the BLK ARC, the point cloud reveals numerous details, including ceiling installations like ventilation systems and pipes. Additionally, it even displays all the cables that are installed. Another implication of this point cloud is for the health and safety officer to verify that all emergency exits are fully accessible and that escape roads are unobstructed. As you can see in the point clouds, we have a wide range of possibility. The use of point clouds, and maybe I'm talking a little bit more about this one. The use of point clouds in capturing and managing the as-built status of facilities or buildings represents a significant step forward in facility management and planning. For example, as-built documentation. Scan data provide a detailed representation of the facility's current state. It is useful for maintenance, operational management, reconstruction, and renovations. Or element classification and extraction. Predefined elements, for example, doors and windows, can be identified and managed directly from the point cloud. This supports inventory management by determining counts and dimensions. If facility or production planning is relevant for you, mobile laser scanning with the BLK ARC enables a replanning of production sites with accurate spatial awareness. If it assists in verifying equipment fitment, ensuring smooth integration of new machinery. You get a detailed visualization. Laser scanner can capture complex details like ceilings and installations, ventilation systems, pipes, cables, machinery, and water hoses. Therefore, facilities will better understand and be able to analyze the local situation without the need of physical access on site. And of course, modeling and measurement. The capture point cloud can serve as a basis for creating 3D models for the direct measurement of dimensions within the point cloud. One of the most fascinating use cases for my phone, maybe because I love water, and among my favorites is the as-built scan of the Great Barford Bridge, which spans the river Great Ouse in Bedfordshire. Very difficult for a German to pronounce all these words. However, in this scenario, a remote-controlled catamaran was used as the carrier with the BLK ARC powered by a power bank housed in the black container, as you can see on this image on the left side. SLAM initialization occurred while the catamaran was in motion. Please note the BLK ARC offers two initialization modes, one while stationary and another one while in motion. After the ARC began scanning, we directed the boat towards the bridge and underneath the cascades, capturing the entire structure from the water. A feature that was previously impossible. This video now showcases a point cloud autonomously captured in a chemical plant, highlighting the exceptional level of details achievable with the BLK ARC. The scanner reveals features ranging from concrete pillars and tanks to ceiling installations, building foundations, and much more. Scanning is equally effective indoors and outdoors. However, it's worth noting that rain can affect the quality of scans. Towards the end of the video, you can see the example of transforming the point cloud right now here into meshes and even creating models out of it. This was all done in Cyclone, our Cyclone software. The applications in the chemical or the plant context can be firstly the infrastructure analysis, meaning a detailed scan of the plant's layout and components, helping engineers assess structural and operational integrity. Second, planning and retrofitting, which is very useful, for designing upgrades or verifying the fitment of new installation like tanks and pipes and machinery. Third, maintenance and planning. It is a very common and daily task for people working in the chemical plant. The point cloud provides a visual and measurable data set to identify the wear and tear of or potential hazards in ceiling installation, tanks, and foundations. And finally, again, safety compliance. Accurate scans assist in ensuring whether safety regulations by highlighting areas needing attention. Autonomy is not the only advantage of using a robot. Sometimes remote control is equally valuable, as I mentioned at the introduction. This approach allows the robot to send it into areas that pose potential risks to humans, such as contaminated areas, or, like in this example, fully operational high-voltage substations. Laser scanning of substations is an invaluable tool for capturing details, accurate and comprehensive spatial data. It supports a wide range of application in design, maintenance, and operational workflows. Spot, in this case, ensures a remote and safe data collection. It captures data without requiring personnel to enter high-risk areas, such as live zones or the high-voltage environments. And mostly important, it reduces the downtime as scanning can be performed while the substation remains fully operational, a massive cost factor. Use cases are similar again, ranging from aspect documentation, modeling, and design and planning and more. But of course, the flexibility of the BLK ARC also allows you to use it, for example, on a backpack, as you've seen before, and you walk through the environment without being a robot, using a robot. An undercommon example is a mining scan. Please note that this mining tunnel was completely dark. So we have to use an external light source that allows us to scan in this dark environment. We needed the light for the visual scan, but also for colorizing the point cloud. And the ring start is again astonishing. And keep in mind, this point cloud was captured around 10 meters with a total length of 300 meters of a mining tunnel. And as you can see in this point cloud, every single details from cable, from ventilation installations, from closets, from protection bars, everything is fully available and you can see it. This is also a very nice one. In the previous version, the Spot was used as the carrier platform. In this project we have used the backpack. So the BLK ARC was mounted on the back, on a backpack, and in this case, I scanned that one. We just walked through this environment in a single run. And again, I want to draw your attention to the level of details that are possible with the BLK ARC. You can easily scan and potentially model pipes and cables within a few millimeters of diameter. Again, a unique strength of the BLK ARC. And again, if you look at this level of details of this dumper, you can even see the dirt on the tires. Sewer scans. We frequently receive inquiries about whether the BLK ARC can scan a sewer. The answer is yes and no. For optimal results, we recommend scanning sewers with a minimum diameter of 1200 millimeters or 1.2 meter. There is a strong and increasing demand for scanning underground structures like culverts. In one instance, we scanned a large sewer shaft by recording the surroundings on site and scanning into the sewer from below. We didn't stop at just one sewer. We also scanned the overflow, as you have seen previously in the video. We also scanned the overflow by putting the arc above this area of protection. And the entire process just took 15 to 20 minutes to scan on above ground and underground. While it is possible to scan sewers with the arc, the structures needs to be of a certain size, as I mentioned before, to achieve satisfactory results. My last example today is a scan that happened just last week on a highway in Austria. With that, we analyzed together with our customer how well the ARC can be used to document as-built status of highways and highway-related infrastructure. Please note the intention of the ARC is not to drive with 100 km along the highway or that we have our fantastic TRKs. Here it's meant to work on a detailed small-scale level. With that, we have also tested the amazing classification tools, as you have seen in the video, of Cyclone 3DR. And the results were pretty impressive. Every detail was scanned in 20 minutes, from curbstones, fences, road surfaces, lampposts, vegetation, and guardrails. By easily filtering out by passing and parking cars allowed us to simplify the digitalization process. That's where I want to end. It's really about point cloud classification, because with that one you can do much more, as you have seen in the previous video already, the classification outdoor. Here is really about to add easily intelligence to point clouds. In our Cyclone 3DR software, you can, as you can see in the video, by a simple mouse click, classify the point cloud and easily remove, for example, moving objects like bypassing people, bypassing parked cars. This is a quite simple progress and really requires only a few button clicks. Previously, we have done the classification outdoor on road. Now we do the classification indoor. It already run, and now you can see how easy after road classification is the classification of point clouds is essential for extracting meaningful insights and organizing the data for a specific application. Classification assigns AI-defined classes like wall, pipes, floor, vegetation to each point, making the data integratable and actionable. It reduces manual effort and accelerates workflows, especially in complex environments like factories or construction sites. One of many benefits is to remove unwanted objects easily. This video, I think, easily illustrates, and it is pretty amazing. So with a few buttons clicks, you can remove all the furniture and you have your blank room available. With that, I would like to hand over back to Anne. Thank you all for joining us, and I'm happy you enjoyed, and I hope you enjoyed the last few minutes with us at Leica Geosystems. Anne, over to you.
Thank you, Johannes and Julita, for the great presentations. I hope you all are already thinking how you could use mobile laser scanning in your business. Before we end the webinar, I want to remind you that if you have any questions to our sales teams or you'd like to start your mobile scanning journey, please contact us right away. If you are in US or Canada, you can directly reach out to Bruce. For the rest of the world, I recommend sending an email to Johannes. You can see both of their emails on this slide. You can also anytime go to blkarc.com to find more information. If you fill the contact form on the website, it'll also reach us. And to all the questions submitted to the Q&A, we will share the answers after the webinar. Thank you once again from my side, and have a great day.